Grade 9. Grade 9, grade 9, grade 9, grade 9, grade 9, grade 9. And I'm very sorry for coming in late. We're supposed to start at 7. I'm very sorry, guys. Very, very sorry. Extremely sorry. Grade 9, grade 9, grade 9, grade 9. Alright, hello grade 9s, hello, 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 hello. Let's see, we have Smasha, we have Tingasa, we have True or False, we have Ace. Hey, True or False? Hey, I son. Can we tap on the screen, guys? Tap on the screen so that we can get this thing visible for many people. I see people must have had a hard time waking up as well, just like I did. Can we tap on the screen, guys, just to get this thing rolling? I think I'll tap on the screen for myself, no problem. Calling on all grade 9s, only grade 9s, guys, grade 9s, grade 9s, grade 9s. My maths people, where you at? Grade 9. Okay, I'm gonna wait for some people to join in because I see we do not have our regulars. Men van Staal. Man. Hello Mini, I see Mini, you are here. Yeah, just waiting for some of the others to join. So I'll start at 7:30, just 5 minutes. I just want to wait for people that are regulars to come in. I'm just a bit sorry that it started a tad bit late, but we can tap on the screen for now, just for the purpose of this being visible to many others. You know, it's nice when this thing goes onto the FYP page, then more people can get a chance to be exposed, right? Grade 9, maths now. Grade 9 maths, grade 9 maths, grade 9 maths, grade 9, grade 9, grade 9. So what you should be seeing before you should be seeing a very white screen. White screen, nothing yet. I've not done anything yet. Calling on all the grade 9s, all grade 9 maths learners. Let's come on in. Let's come in. Let's come. Otherwise, I hope we slept well. We are waking up well, and we are looking forward to a wonderful, good Saturday in our respective places where we have woken up. Yes, so this is grade 9 maths, guys, grade 9 maths. Okay, please just give me allowance to wait for certain people to come in and join the session. Like I said, I'll start shortly, but I just want at least majority of the peeps that usually join to come in, and yeah, they should be joining us shortly. I will be starting shortly, so just be patient with me. Patient. Okay. Yeah, today actually we are going to look at we're going to start with financial maths, guys, today for the grade 9s. We are going to start a topic called financial maths, financial mathematics. We are going to be talking about money today. Money. But before we do that, we are actually going to before we do that, before we jump into talking about money, financial maths, we are going to actually do some of the corrections, right? The corrections that we did. The corrections of the work that I gave you yesterday. Hopefully we can remember that I gave you some work, and and I'm hoping we were able to do it. Can we indicate in the comment section if that work was done, the one that I gave you on indirect proportion? Can I just get an indication in the comment section that that work was done? Can I get a done in the comment section? Comment of saying I did it. Done. Okay, thank you so much, Mini. Thank you, Mini. Okay. All right. Yeah, so let's at least start off there and correct. Let's correct this work. Let's start exactly there. Start out by correcting the work. Okay. YouTube handle Tabo Bungani. You can go to the bio, my good friend. The bio. My bio there has the YouTube handle. It's like this. It's at maths. Same name as the YouTube channel. It's at maths, and forgive me for my romantic handwriting. At maths is a game 5 to 7. Okay, that's the YouTube handle, and in that YouTube page, I'm basically uploading all the videos of the live sessions that I do here. They are raw and unedited, so you get them. You can see what's happening now. We were moving around, that type of thing. Sometimes I don't even start immediately. Sometimes I will talk first, and it may take a while. Then I eventually start. And then even in between the lessons, as I teach, there are certain things according to the comment section that I will notice, and I will comment on those things. So yeah, it's raw like that. So that is the YouTube handle. Maths is a game, 5 to 7. This 5 to 7 is supposed to indicate that this is the level of performance we are hoping to be within the range when we are doing mathematics. We can't be getting something less than level 4. I mean, less than level 5. We get 5, 6, 7. That's what we need. And yes, maths is a game. Why? Because there are rules in maths. And then once you know the rules, then you can play the game, right? Because even games have rules. Once you know the rules, you can play the game. You can play it a lot whilst following the rules, and then pass with distinction. Pass with distinction and merit. That's what we want. But you can go to my bio. The link is there. There are 2 links on my bio. One is for the WhatsApp channel, where I sometimes just upload work and past papers, and then the other one is the YouTube channel, which is where I've uploaded the videos of the live sessions that I've done so far since we started in December. Because we started in December, we've been pushing this passion. We've done work according to the ATP for this year, 2025, for the grade 9s. And at the beginning, when I started, I did the work for the grade 9s that was similar to what the grade 10s do. So when you go to my YouTube channel, you'll find that the first few videos, I've actually combined the lesson for grade 10 and 9. So you will see in the thumbnail, I've written grade 10, then a /, then there's 9, because the content at the beginning for grade 10 and 9 is very similar. So I combined their sessions. So it will give you great benefit to watch those sessions before, so that you must understand that now we are at a certain place with regards to the ATP work. Yesterday we started doing indirect proportion. We had done before that direct proportion, and there's work that I usually give at the end of the session so that people can go and practice for themselves and see if they are able to apply the rules, play the game, and get the 100% that we want. So let's look at the corrections that I wanted from the game challenge yesterday, hoping that everybody who was here yesterday did the work. So here we are. There are 2 mothers. That was the first question. There are 2 mothers. One mother has 3 children. Okay, let's hold that. One mother has 3 children and can give each child 12 sweets. 12. How many sweets can the mother give each child if she has 6 children? So here, first and foremost, I'm sure we can see that the quantities we are dealing with are 1, we are looking at children. 2, we are looking at the number of sweets that the children get. In fact, we are looking at specifically the number of sweets that each child can get. Right? So let us first record our information. So we have to then say children, and then sweets. Those are our 2 variables. We set up a table there so that we can record the information that we have. So what did they say? One mother has 3 children and can give each child 12 sweets. One mother has 3 children, can give each child how many sweets? 12 sweets. I hope you can see, guys. Then the question is, how many sweets can the mother give each child? How many sweets? We don't know what the sweets are. How many sweets can be given? How many sweets can the mother give each child if she has how many children? 6. So we want to know how many sweets. So that means we let X be the number of sweets each child will get. Because the question says, how many sweets can the mother give each child if she has 6 children? We know how many sweets each child gets if there are 3 children. But now we are interested to find how many sweets will be given to each child if there are 6 kids, 6 children. So yes, this is our first quantity, children. This is our second quantity, sweets. And we have let X be the number of sweets each child will get. Then what we do, if you remember, we then rewrite or reframe the table so that our X is at the left, at the top column. So that means our sweets will be now written there and the children will be written at the bottom. With X goes with 6 children, whilst 12 goes with 3 children. We write the X at the top, at the left, so that we can do what? So that we can set up our equation. But before we do that, we check something very quickly. If 6 children, each child is getting, if there are 6 children, all right, and we can see from 6, what's happening here, this side, from 6 is 6 children to 3 children. My question is, what if 3 children are getting 12 sweets each? What is the possibility of what's going to happen with 6 children? Will they be getting more sweets or will they be getting less sweets? I repeat, if 3 children are getting 12 sweets, because we need to ask that question, what are we expecting will happen to the number of sweets as we have more children? Are they going to get more than 12 sweets? Are they going to get less than 12 sweets each? So Minnie says less sweets. Do we all agree with Minnie, or is there someone else that is saying aye? If there are 3 children and they are getting 12 sweets each, what are we expecting will happen if there are 6 children? Will they be getting more than 12 sweets each if there's more children, or are we going to be getting less sweets if there are more kids? What is happening? So Sepak is saying more than Dennis. Okay, Minnie is saying less. Right? I repeat again, guys. 3 children are getting 12 sweets each. If we increase the number of children, will they be getting more sweets or will they be getting less sweets? All right, and I have to agree with Minnie. All right, they'll be getting less. So here is what's happening here. Here, from here to here, what's happening? There's an increase. If I move with my arrow from here to there, there's an increase. From here to there, if we are saying this number of X will be less than 12, that means that here, this side, there's a decrease. What did we say will accommodate a quantity where there's an increase in one quantity, whereas on the other one there is a decrease? We know that is inverse or indirect proportion. All right. And what do we know about inverse or indirect proportion? We know that the product remains constant. All right, the product remains constant. So when we set up our equation, we are then going to say this x and this 6, we are going to multiply x times 6. And then this 12 and this 3, we are also going to multiply, because the product is constant where inverse or indirect proportion is constant. That comes from the definition of what we understand inverse and indirect proportion to be. Remember, if it was a situation where we set up the table and we find as one quantity increases, also the other one increases, then it would not have been indirect proportion, but it would have been what? Direct proportion. And therefore, when we set up our equation, we would be talking about the ratio being constant. What is ratio? It means that if we take x and we divide by 6, meaning x over 6, and then we take 12 over 3, then we would set up the equation in that way. But this is not direct proportion, because here we see as one quantity increases, the other one does what? Decreases. So we set up our equation in that the product must remain constant. So x times 6 is equal to 12 times 3. Then we work out the maths from there. What's x times 6? X times 6 and 6 on the other side, 12 times 3. X times 6, 6x. 12 times 3, 36. Then what do we do from here? We divide both sides by the coefficient of x, which is 6. What we do on the left, we do on the right, we get an x which is equal to 6. All right. Did you guys get that right? Those who did the work, the game challenge. Can I see my people that were able to get this right? Thank you, Minnie. Good job, Minnie. Great job. I'm happy, which means yesterday when you learned the concept, you grasped it, made sense. Wrong was amen. You know, what I like about this name, wrong was, you would think that wrong ones would get this one wrong, but you got them right. So I think we need to change your name to Rightwa, not Wrongwa, Okay, Rightwa. So hopefully we were able to get that. Nice, guys. Very beautiful, very excellent, very sweet. Let's move on. Next question. The next question says, if 6 men can dig a ditch, okay, a ditch is a very big hole, guys, very big hole. It's like a trench. If 6 men can dig a ditch in 2 hours, how many men would be required to dig the ditch in 3 hours? Right? Repeat again. If 6 men can dig a ditch in 2 hours, how many men would be required to dig the ditch in 3 hours? So as we process, I'm sure we are processing, and the process is processing, and we are processing. All right, let me move to beautiful white paper. 6 men. So we set up 2 quantities. What's the 2 quantities? All right, our 2 quantities that we have there is men and time. Time taken to labor or work. So the time taken to labor or work. The question is saying, if 6 men dig a ditch in how long? 2 hours. Okay, so this is time in hours. Then they're asking, how many men? So that means we want the value of x there. How many men will be required to dig the ditch in what? 3 hours. So we reframe, obviously, our thing so that it accommodates x at the left, at the top. X goes with 3, whereas we know 6 goes with 2. So that means at least here we still have our men at the top and our time at the bottom. Okay, remember people, the only reason we do this is just so that we can have this, we're doing this. This is just the method, all right? Then let's ask ourselves and check something. What are we expecting will be happening to X? If there are 6 men and it takes them 2 hours to dig a trench, what are we expecting will happen in 3 hours? In 3 hours, are we expecting more than 6 men to be working, or are we expecting less than 6 men to be working? Remember, it took 6 men 2 hours. So is it more men that we need to do to complete the work in 3 hours, or will it be less men that will actually be completing the task in 3 hours? Let's make logical sense of this. Obviously, I'm sure you can see, guys, if 6 men are taking 2 hours, how many men would be taking more than these 2 hours? Right? Will it be more men that will be taking 3 hours? If we increase the workforce, are we expecting these people to basically finish the work having used more time, or will they be using less time? So how many men? Is it less than 6 that will accomplish or complete the work in 3 hours? Will it be less than 6 men, or will it be more than 6 men that will complete the work in 3 hours? So let's try and apply some logic in this thing. Less men or more men completing the work in 3 hours. All right? Yeah, because I want to repeat this thing. It says if 6 men can dig a ditch in 2 hours, how many men would be required to dig the ditch in 3 hours? All right? Think about it yourself. All right? Okay. More men will take less hours to finish the work. More men. Okay. But you can see from here to there, this is more hours. Are you with me? Think about it practically. We are busy with some digging here. All right. If I deploy more people to do the work, they will take less time, Kaloko. More hands will finish the work in less time. But you see what's happening here. From 2 to 3, this is more hours. So what are we expecting? The people who will finish the work in more hours are obviously less men. Okay? Thank you so much. You guys are getting the point. So this is the logic we need to think about. When we look at this scenario, please, let's think about it in real life terms. Don't be too romantic. Please, people, think about it in real life. You are setting up this thing so that you can be able to apply real life logic. Common sense. Yeah, they say common sense is not common anymore. We must apply common sense. So 6 men are taking 2 hours to dig a trench. Will it be more men that will take 3 hours, or will it be less men that will take 3 hours? Obviously, that means that less men, we have a less working force, less labor being applied. That's why these people are taking a long time. Are you with me? So I'm sure you are noticing something here. From here to here, we are increasing. So as the time, if the increase of time, what did we say we expect with the men? There'll be less, which means there's a decrease. From this to there, decrease. From here to there, increase. You can look at it the other way if you want. From here to there, increase. From here to here, decrease. So all in all, we know that this quantity As it increases, that one decreases. Or we can say vice versa. As this quantity increases, because we're coming from less to more, this quantity does what? It decreases. So what type of proportion are we talking about here? We are talking about inverse or indirect proportion. Guys, this is so important. What you are able to ask in that question and how you answer it, less or more, will help you understand whether you are dealing with inverse or indirect proportion. Or direct proportion. Once you know it's inverse or indirect proportion, then what do you know about indirect and inverse proportion? This means that the product remains constant. Yes, you can. Just join my YouTube. Just go to my bio and subscribe to my YouTube channel. I will be uploading these there, right? Or maybe because some of you are screen recording, and that's also helpful because screen records, you get it on live time and you can see it as it is. So inverse or indirect proportion means that the product remains constant. When the product remains constant, you see the x is at the top on the left as we want it or as we like it, then we can deal with the product. X times 3 is equal to 6 times 2. Because this is what? Indirect proportion. The product remains constant. It would have been a different story had we found out that as one quantity increases, the other one increases. Then we would have talked about direct proportion. And for direct proportion, the product does not remain constant, but the ratio is constant. So we would have said, if it was direct, x over 3 is equal to 6 over 2. Makes sense? Let's go. What's x times 3? 3x. What's 6 times 2? It's 12. Now we can solve for x. We divide both sides by what? By 3. Then we get an x which is equal to what? 4. So what is the number of men that will be required to complete the job in 3 hours? It's 4 men. And I would say it's raining men, guys. Hallelujah, it's raining men. You know, that's 4. 4. All right? Which makes sense. Because the less number of people you have doing a job, those people will take long, those people, you know. So we need to apply that common sense so that we can get the right type of proportion and then set up our equation 100% correct. I hope we are together here. We are feeling each other. It's very key to feel the work. Then guys, you had this work which was you were supposed to do here, where you're supposed to fill in the table. Alright, table filling in. They said here, find the values of A and B. And if you look at the table, we have X, we have Y, we have 6, we have 4, we have 8, we have blank, we have B, we have 12. Yeah. So you look at this and you're like, all right, what is happening? All right, what is happening? How do we find the value of A and B? Right. So what did we get, guys? The value of A and the value of B. I want to see, and maybe you can tell me in the comment section how you went about finding the value of A and B. Let's check what the people got. Table has been set up. What is A? You can just say A is equal to and B is equal to. And then maybe you can tell me how you went about getting those values. Right? These are questions that usually even come in tests. You just get given a table and they like find the values of A and B, and then you're supposed to actually go ahead and find the values of A and B. So I'm waiting. Very patient in waiting. A very patient guy. No hurry. Okay, so this is, let's understand one thing. All right, maybe there's something I did not mention here. Okay, So can we, okay, these are inverse proportion tables, all of them. They are all inverse proportion. So maybe that helps a lot in helping us there. And that's something I did not bring out. But because we are doing inverse proportion, okay, I did tables that are inverse proportion as well. So we have 6, 4. So this is one quantity x, this is one quantity y. And these are supposedly supposed to be inverse proportion. I'm sure you guys can see what's happening here at the bottom. Okay. So what did we get, guys? A and B. So does the silence mean that one, it really, we were unable, or I just need to maybe understand. Did that one, were we unable to get it? Is that why we are silent? I didn't understand it. Alright, Mini has come out at least. Thank you for your honesty there and vulnerability. I really appreciate it. What about the masses? What about the masses? Yes. Please do try. This is the whole point of being here, is to try. Please try. I don't want to jump in and just... Yeah, so at least now I've told you these are inverse proportion type scenarios, not... Okay, so I think I omitted to do that to you and tell you what type of proportion it is. But I guess I assumed that since we were doing the topic of inverse proportion. So they tell you that in the table below, x and y are inversely proportionate. So if they're inversely proportionate, then that means that they want you to find the value of A and they want you to find the value of B. Okay, so if that is the case, thank you so much, Busiso, for the rosa. Wow, that's very nice. Very generous of you, sir. Much appreciated. So, hey, and the ice cream, Baba. Thank you so much. What generosity in the morning. Really appreciate it, sir. Thank you. Means a lot. All right, guys. Let me help us out. Okay. So, like I said, this is inverse proportion. Inverse, right? So, this is what I can tell you. If you are looking at the first column and the second column, these two columns, right? If it's inverse proportion, what do we understand? This quantity is what at the moment we can see this quantity is increasing. What are we expecting with 4 to A? Let's forget about the last column, guys. Let's look at the two columns. They have told us these are inverse proportion type question. Okay, so let's forget about the fact that when you are looking at this and you're like, I wonder what's the pattern. No, they've told us these are inverse proportion tables. So let's forget about this column for now and look at the given column where we have information, and look at the given column where there is a piece of information but we don't know something else. Let's forget about this guy for now, the last column. Are we together? So we need to isolate so that we see something familiar. So what are we expecting? If this quantity is increasing for inverse proportion, we know that the other quantity must be, if this one is increasing as we see it is, this one must be, I hope you understand. If this quantity is increasing from 6 to 8, this quantity at the bottom is what? Is decreasing. Okay, because we know inverse proportion says or states as one quantity for two variables, as one quantity increases, the other one will decrease, or vice versa. Okay, yes, I am going to do that, Princess. As one quantity increases, the other one decreases. All right. So we need to then apply that knowledge, because we know that these tables are inverse proportion tables. That's great, Minnie. I'm happy that you've now found A. I'm very happy. Okay. So what we are going to do, we are just going to take these two, 6 and 4, 8 and A, and just write it aside. 6 and 4, 8 and A. That's our table, right? Because now we know we work with tables. We have X here, we have Y there. Then reset the table. A goes with 8. Ne? 4 goes with 6. Reset our table so that the unknown is at the top, at the left. All right? Is at the top, at the left, so that when we set up our equation, it's easy for us to set up. We were told this is an inverse proportion relationship. So that means our ratio is what? No, not our ratio. It means our product for the different quantities remains constant. So 8 times 8 is equal to 4 times 6. That's what, that's the concept we apply for inverse proportion. Okay, I hope we are getting it now. 8 times 8 gives us 8A. And then 6 times 4 gives us 24. Then we want to solve for A. Then therefore what do? We divide both sides by the coefficient of A, because 8 and A have a relationship of multiply. So we divide by 8, but what we do on the left, we do where? On the right. Our final answer is A is equal to 3. Did you get that, Minnie, as well, and other people that basically then saw, oh, okay, this is how we do it. Yes, people, this is how we do it. All right? Yeah. So, yeah. Yeah, so if those are inverse proportion type, then this is how we would attempt to find the value of A. So this is not simply just us going and, writing the answer, thumb sucking the answer. Remember, for inverse proportion, we've learned something. That one, inverse proportion or indirect proportion means as one quantity increases, the other one decreases. So we have to come to the table and apply that knowledge for the two columns, because we have two knowns, 6 and 4, for X and Y. But then if we go to this column, we can see we have 8 as X, but we don't know what Y is. So let's work with those two. What did they say the table is? It's an inverse or indirect proportion relationship. What do we know? We know that as one quantity, as we can see here, this quantity is increasing. But this one here, surely it cannot also be increasing. This one must be a decrease. Why? Because we were told this is an inverse proportion type table. They could have given us another table and told us that this is a direct proportion table. Then if we would have looked at the two, we would have looked at them differently. Because for direct proportion, if the top is increasing, then this one is also increasing. Are we together, guys? I hope we're feeling this. Then how we set up the equation would be different for direct proportion. Because for direct proportion, the ratio is constant. So we wouldn't have had a product. Rather, we would have had a fraction. A over 8 divided by 4 over 6. But this is not direct. But that's what we would have done if it was direct proportion. Hope it makes sense, guys. That's how we get A. We get A in that way. Now we want B. So what we do is we forget about the middle. We focus on the 6 and the 4, the B and the 12. So let's go. 6 and 4, B and 12. Okay. Junior is saying, can you do for the hypotenuse? When you are talking about something else, a different topic altogether, we are talking about something else, you are coming with another. If you want, you must wait, my friend. We are busy here doing grade 9 maths. We are following the ATP. We are now doing corrections on indirect or inverse proportion. We have done some of the other topics for the beginning of the term. All the videos for the live sessions are uploaded onto the YouTube channel. You can find the link of the YouTube channel on my bio. It's there. Then you can watch all the other sessions. Okay, so yes, okay, yes. Hypotenuse and stuff come later in the year as far as the syllabus for CAPS is concerned. So that's coming up. But for now, we are busy with this section, and this is a section we need to know and master as well for now. So let's look at this, guys. So we know already this is an inverse proportion type. So here we can see 6 to 4 is increasing. So here to there, we know it's going to be decrease, because we can't have increase for inverse. It's increase, 6 to 4 is increasing. From 6 to B, we are expecting a decrease. Mashallah, by mashallah, mashallah, mashallah. Okay, then what we do then is we set up B on the left at the top. Under B we have 12, 6 we have 4. So we set it up nicely there, reset, okay. Then because it's inverse proportion, we know most the x and the y, they fall there. Sorry about that. X and the y, because that's still x and y. Then what we do is we say b over 12 is equal, not b over 12. We can't say b over 12. Why? Because this is indirect. Indirect means product, b times 12. So we need to always be alert, guys, when we write these things, so that we write the right things. B times 12 is equal to 6 times 4. B times 12 is 12b. 6 times 4 is 24. Then what we do is then we divide both sides by the coefficient of b, which is 12. Okay. Coefficient means the number before the variable. That's what the coefficient is, okay, in algebraic terms. And then we find the answer b is equal to what? 2. You see, guys, then we can go and populate our column. All right, if let's say for instance they had given us space in the column to populate our value, the value is there. Makes sense, guys? Thank you so much, Sapak. I appreciate the blessing, the pronouncement. From the abundance of the heart, the mouth speaks. Thank you so much for those blessings. I know it's coming from the abundance of your heart. Really appreciate that, my friend, my sir. So I hope it makes sense, guys, that A and that B, how we got that A and that B, using this concept of the product for inverse proportion. The product remains constant, for indirect. Then let's look at the next one. Okay, guys, I'm going to give you this one to do, and I'm going to wait for you. I'm going to wait for a good 10 minutes. I'm going to give you a chance to do B on your own. Right? Remember, this is also inverse. They want the value of A and the value of B. Let's go. Grade 9. Let's go, guys. Let me give you a chance. I'm going to give you 5 minutes to do this one on your own. 5 minutes, guys. You have 5 minutes. Okay? So I hope we are busy. Taking out the pen, we are writing. You are doing. All right? I don't want to spoil the fun. I did one for you. You saw how I did it, right? Now I want you to do this one for yourself, so that you can also have that sense of confidence that no, man, it's not say only that can do this thing. I can also do it. Yeah, but it's easy peasy. Thank you, Smo. Hey, Smo is very generous this morning, my friend. Thank you so much. I really appreciate it. Hey, thank you for those ice creams, Baba. It's like it's cooling down the what you might call it's cooling down the esophagus. I think as life science people will correct me. I think they call it the esophagus. That part where it's like things go down. As you ingest, as you ingest things, they go down the esophagus. So those who are joining in, unfortunately, if you are just joining in, I'm just giving people a few minutes to do this problem. Obviously, I want the values of A and B. So I'm hoping that the minute someone is able to get a value, please, in the comment section, you tell me what the value of A is. The minute you get it, and then you do the calculation, please, let's practically do the calculation. Then we get the value of B. You tell me in the comment section what the value of B. We will compare what people's responses are. And please, let us not copy and paste someone else's response. You might just be thinking you are copying the right thing, but in actual fact, yay, the danger that is, Junior, you are welcome. This is my love and my passion to give, because I have been given much as far as that knowledge, and being able to give it to others is my pleasure. Glory be to God. Thank you. Glory be to God. Oh, Mini got a value. I wonder, what do other people have to get for as far as A, right? So that means you are doing it, Mini. Thank you so much. I will confirm the answers later on, not now. Mini may be very wrong, actually. You never know. Or she may be very right. We never know. The only way person who knows would be her. If she's done everything in the manner in which it ought to be done, understanding the concept of inverse proportion, which is very key. Very, very key. How key it is. Wrong was also got 6. Peer pressure now. You can see the masses there are busy. They're like, hey, let me just write that as well. Mini is moving very swiftly. What I love, Mini, is that even wrong was. What I love, guys, is that, so if you remember, it was 8:10 when I said, I'm giving you the work. Then I said at 8:15, I'm giving you 5 minutes, actually. So now the time is 14 minutes past 8. If you are able to finish the 2 within that 5 minutes, then it means that you are not only, and if you are accurate as well and it's correct, then it means that you are not only doing things accurately, but also you are cognizant, you are sensitive to the time it's supposed to take you to finish that problem. Remember, even when we are writing tests in the test situation, they'll tell you in the paper you have how many hours to write. So the important thing here is being able to first understand the concept. How nice it is when you do maths and you're like, I understand what I'm doing. It's not like this thing, it's like I had to, what you might call, nkaya. Is it nkaya ring? Yes, it's nkaya ring. Some people, they nkaya the maths and they think that that's good. No, guys. Nkaya ring, or whatever you guys call it, maybe in other languages they say it in another way, but cramming, yes, it's called cramming. You cram, knowledge gets saved, it has a short shelf life, it stays for 2 minutes. After 2 minutes, it's gone. You'll never get it again. So practicing maths helps us to internalize. It's like we are keeping the knowledge in the permanent storage, in the heart and the mind. Once there's the love and the passion as well, you store it in the permanent storage, and then you can use it even in many years to come. So that's very important. So that's why we need to do the maths. Do it. It's not good enough to just hear it and say, oh, say, I love it. You are doing so nice. Oh, I love it when you are doing it. No, you must also do it so that it can be nice for you. You can feel good, Spend time with maths. Spend time. Have time. Personal time with maths. Love maths. Fall in love with maths. Fall deeply in love with maths. And then you'll see, the difference that will make. Okay, guys, the time that I've afforded you to do the problem is now sufficient. Okay, so very quickly, we know that we isolate the column. Forget these last two. The last one, the last column. Look at the first two. So here we are seeing 6 to 5, there's a decrease. So since it's an inverse proportion, it means there will be a increase this side. There's a decrease here, so we're expecting a increase, that's this side. All right. Then all I do, okay, I'm going to reframe this table and write A at the top. A was going with 5, and then A was also next door having 5, okay, and that 5 had 6. All right. Yeah. So I know this is my new table. I would set up a sort of like temporary table so that A is at the top at the left. Then, because this is what? Indirect, meaning as one quantity decreases, this one should increase. Then it means my product, A and 5, product means multiply. The product is constant, guys. A times 5 is equal to 5 times 6. The product is constant. So I get 5A is equal to 30. 30, guys. Then I do what? I divide both sides by the coefficient of A, which is 5. I get A, which is 6. Ne? So right, Rongwas and Mini were 100% spot on. Good job, girl. Good job, guys. Good job. Then let's look at B. So to get B, we are going to isolate again. Look at the first and the third column. Look at the first and the third column. There's already information 6 and 5. We use this one as well. We isolate. Let's just reframe B at the top. Remember B with 6. And then under B we have 10. And then under 6 we have 5. B at the top, at the left, the order and the values are the ones that are still there. So we're expecting as one does something else, this is a decrease, this should be a increase. Are you with me? Yeah. So we know that the product is constant. B times 10 is equal to 6 times 5, because this is inverse proportion. People were told it's inverse. What a different story it would have been if we were told it's direct proportion. Then we would have looked at the ratio being constant. We would have said B over 10 is equal to 6 over 5. You feel this thing, guys? Direct and indirect. Yeah. Very key, very key. 10B is equal to 6 times 5 is 30, guys. Beautiful. Chini, Mini, and Rongo. Hey, these people, they always knew the truth, these ones. So really, B is 3. So Rongo and Mini were 100% correct. A is 6 and B is 3. Voila, guys. Yo, you guys. Ay. You guys. Ay. There's no one. Ay. You guys. Ay. I feel you, guys. I feel you there. Right. Take note, there was a question that I had asked where I said to you, draw a graph of B as well. I just want to look at that very quickly. Drawing the graph of B with the values of the table now finished. We have the values of the table. I just want to check these out. So very quickly, we have the table. And I want to go ahead and draw this graph so that you guys can also see how we go about drawing the graph. And then this one, guys, you can do as well on your own. Okay, maybe you can quickly write this down. This is also inverse proportion. This time round we have decimals. Not comma 4, 2 comma 5. Not comma 2, we want the value of A. 4, we have B. We want the value of B. So we want the value of A and B for this one. This is also inverse proportion. So you can quickly jot it down if you don't have it, and then you can actually do it. What I want to do is I want to conclude this session not with C. All right, you guys can actually now do C on your own time. Then B, I want to just show you how you go about drawing the graph, because they asked us to draw a graph, and we want to see how this graph will look like. All right. I have to have the grade 10s at 8:30, so I don't want to start late like I usually do. I want to end at least a bit early so I can start with them. Okay, so then you guys will do that, and then we'll start with financial maths tomorrow. Ne? Guess we needed to do this one. Mini, do you agree? We needed to do these corrections, Mini, so that you guys don't leave here feeling like, hey, that one I don't know. Do we thumb suck? Do we just guess? Do we assume? All right. They will tell us, what the table is. It inverse or indirect? Is it inverse or is it inverse proportion, indirect proportion, or is it direct proportion? Then we can know what to do to find the missing values. Okay. All right. Now I want us to see how the table is drawn. So remember, x and y, we have 6, 5, b. B we found, ne? B we found it. It's what? It's 3. Then we have 5. A we found, it's 6. And then we found B with 10, that's 3, and so that's 3 and 10. Junior is asking, are you live every day? I try to be, but, and I have been, all right, since December. So that's why I'm saying you can go to my YouTube channel to find the videos that the live sessions I've done since December. Starting from the beginning, the grade 9 syllabus, term 1, the first topic of whole numbers, looking at numbers, the different type, what is a whole number, what is a natural number, rational number, and all of those things. You can see all of that in my YouTube channel, Maths is a Game. You can go to my bio, the link is there, and you can find the sessions I've done previously. Now we are in the later topic of within the first few days in the term's work. Okay, so I will only be able to go live up until Sunday. I go back to work like you guys on Monday. Actually, I'm going back to work officially, so I will not be able to do live sessions in the morning as I usually do, which means I'm going to have a new schedule, but I will post that schedule to the relevant people in the relevant groups, so that people can know when I go live again and which days and when. Okay, because it will have to be obviously later on now, and I'll have to divide my time for the different grades in different days. I will not be able to go consistently live as I am doing now. So hope you understand that, guys. Hope you understand. All right. Anyways, let's go, guys, and look at this. So we have our values. So what we do, this is x. At the top, that's y. So when we draw a graph, people, this is something you need to be very much aware of. When you draw a graph, we have what we call here, the y-axis. All right? And then here we have what we call the x-axis. We call this our independent variable. We represent all x values on this horizontal line, and then we represent all y values in this vertical line. So we would use a ruler, obviously, to draw this. I'm drawing it freehand because at the moment, my lovely people, I have no ruler, and I'm holding my phone with the other hand, so it will be very difficult for me to actually do that. Then let's look at the values that we have. The smallest value in the table that we have is 3. The biggest is 10. So that means for x and for y, we can just do this. You would use your ruler and you would mark this. Using your ruler, 1, 2, 3, 4. You use a suitable scale. 5, 6, 7, 8, 9, 10. So I'm going to end at 10 because I saw that in my table the highest value is 10. Then for y, do the same thing. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. But of course, like I said, you would use a suitable scale. 6, 7, 8, 9, and 10. Right. We see this? Hopefully we can see it, my beautiful people. Now, let's look at the first column. 6, where x is 6 and where y is 5. Let's go. Where is 6 for x? 6 for x is here. There it is, right? And then simultaneously, where is y? 5 for y. 5 for y is here. Now, what you would do is you would use your ruler horizontally and sort of draw this horizontal line up until where you can see it's just above the 6. Then you would do the same thing for 6. You draw a vertical line for 6, and you'd use your pencil to do this so that you can mark the point that actually represents 6 with 5, where x is 6, like x is 6, and where y is 5. This is your point. Are you with me, guys? I hope you can feel me here. I repeat again. You find this is your horizontal x axis with all your x values. These are all whole numbers. Okay, obviously here we'd have 0, 1, 2, 3. So we have whole numbers represented. Then here on your vertical y-axis, you have your whole numbers, right? So we've labeled 0, 1, 2, 3 all the way to 10. Then x is 6. We come here. Y is 5. We come here. We horizontally, using our pencil, locate just above the point 6 so that we can also draw a vertical line and identify the point, which is called 6 and 5. There it is, 6 and 5. Let's move on to the next one. Where x is 5, here is x is 5, and where y is 6, here is y is 6. Then we do the same thing for that. You know, you would do that. I'm sorry for that writing there, you see, but you see where it would be exactly here. No, actually, sorry, I'm lying. So you do that where x is 5. Let's start there. Where x is 5. Where is x 5? It's here. And then where is y 6? Y 6 is here. So what we are going to do is we are going to draw another horizontal line using our ruler, but it wouldn't be a line, it would just be a dotted line because we want to locate the point just above. We do the same thing here. So there's the point. Can you see that, guys? So we have this point, which is 5 and 6. And then the last point, where x is 3, x is 3, y is 10. Y is 10. So horizontal there, horizontal, vertical there. We're meeting here. So this graph, if we are to draw it, goes like this. Okay. It would obviously exceed beyond that, but I'm sure you guys can see, all right, the graph, the shape that it has. This is to show that truly this is inverse proportion, all right, inverse, because our graph is supposed to take on this shape, which is a representation of inverse proportion, okay, very importantly. So this is how we would sketch or draw the graph, okay. Yeah, so this is just rough, guys, but usually what they do is they provide sort of like, let's say, a table for you, so that, or let me say a graph area where the x and the y is there, so that you can be able to just locate the points in that particular thing and then sketch the points. So guys, let's hold it right there. Thank you so much. Grade 9s. I hope you learned. Okay. Yeah, I hope you learned. If there are questions, please do ask. But I guess our time is up, my beautiful grade 9s. I'm going to have to end it here. Okay. Okay. I'm going to end it here. Right. So thank you very much. I now need to get the grade 10s in the house, so I'll be leaving. We'll see each other tomorrow. Do people need to see this, guys? Sorry, I'm just wondering if people want to see this diagram. Okay. All right. Cheers, guys. Let me see you then. Thank you. Thank you. You're welcome. You're welcome.